Hello and welcome back to video feedback before all hands on DAQ. Let's get out of that. So the point of this one is to dig into DAQ, but just in a sort of shallow way for now. The next video after this one will dig deeper into DAQ, but the point of this one is just to give quite a quick, very short, high-level overview of what DAQ does. Before I dive into this, I just want to go to the docs folder. So these are, I don't know, God knows, loads of Markdown files that are more regularly updated by the developers than the wiki. So here's the wiki, which is kind of more like a getting started guide than anything else. It should be the first place you go to if you're new to DAQ. And if you're inducting anyone else into the world of DAQ, then point them here first. But the more in-depth documentation is in the docs folder. So as I say, these are a lot more detailed than the wiki. So we have things, well, we have the first Markdown file is add test. They're all in alphabetical order, of course, so this isn't as if, add test is the first thing you do, build is the second thing, and changelog is the third, because that doesn't make sense at all. So if you've downloaded the repository and you've got a docs folder on your local machine, if you're using a text editor like I am, like VS Code, then you can go into one of these Markdown files and hit something like Control-Shift-V to render the Markdown, so you can see it in a slightly in a way that's more pleasing to the eye than just the raw text. Or what you can do is, if you go straight onto GitHub, go to the code and go into the docs folder, then GitHub will render the Markdown for you. So that viewing the docs folder on GitHub itself is more like reading a tutorial. So any questions that you have that aren't covered here and that aren't covered on the mailing list and aren't covered in any other avenue of questioning will probably be found in the docs folder. But beyond that, in-depth DAQ, the first level of depth. So DAQ should be thought of as a generic test runner. So I just want to run DAQ again. If you're following on in the series, the last set of videos was about running DAQ with a real device. So that was with this configuration here, which I've now called system.at.conf. AT, because that's, for me, it stands for Allied Telesis. And all this configuration was doing is connecting to a switch that I'd set up to run OpenFlow. And I have kind of copied and pasted my old configuration and then just call that system.conf. It's quite a good way to organize different configurations if you're testing a few things. So if you're testing one device on an Allied Telesis switch, for example, testing another device on a Zodiac switch, testing another device on a Cisco switch, you could just have system.cisco.conf, system, and you can kind of swap and change them just by changing the name of the file, like so. So we're going back into the 3-faux mode. So if I just run DAQ again, so what's happening now? We are loading up our faux containers. You see here, loading up deleting the old faux. We're setting up a Python environment. We're reading our configuration file here. So DAQ knows what it needs to do during runtime. We are then loading our GCP credentials for our dashboard. So this is all kind of a setup step. Same with this. And you can kind of see after the info, you've got a little name of the Python module that this log is coming from, topology, network, and then we go into the runner. And this is where DAQ obviously starts running. So what DAQ is doing actually is it's running, if we just go back into our a WD command. There we go. So every time a new test appears, which should happen fairly soon, got ping. Anyway, so every time a new test starts, there'll be another container that appears. Hopefully, just wait until that happens, then I can really illustrate this point. Yeah. Again, so this is a fairly good way to monitor things if you're worried things aren't working. So we've got DAQ 1, DAQ 2, DAQ 3, and DAQ faucet, and then we've got some networking containers up there. Come on. You're making the video longer than it needs to be, DAQ. I'm not entirely sure why I talk to DAQ as though it's a real person. No. This is probably going to be a fast forward section. Wait for DHCP, wait for DHCP. Wait for DHCP. Ping. Port 3. There we go. Got a runner. So yeah, so after the background scan, some tests should start to appear. If we just have a look at our dashboard again. So there we go. Right, so we got a Mudgy. So right there. We have a container that is from the image DAQ test nmap. That's just gone. From DAQ test discover, and we have a container that is DAQ discover 3. So for the sake of argument, let's just have a look at that connection, the discover test, which I believe is in pen tests. Yeah, so test discover. So test discover, each test is defined by a Docker file. And as we discussed earlier, you specify which tests you would like DAQ to run using this host tests configuration option in your system.conf. So local site localtest.conf. Local site localtest.conf. There we are. So should I be running the switches now? There we go. That's probably why something is probably failing in the background. But for the sake of argument, let's say that we have pen tests are done, isn't it? So yeah, pen tests is included within hosts tests. So if we do that and then copy that there, then we are building whatever is in the pen tests folder, which is within the subset folder. And the Docker file is this. So we have from DAQ aardvark, so that's the base image of DAQ. We're going to do it's a sort of a sudo apt update, and then we're going to install nmap, and we're going to install netcat. I'm going to copy this shell script here, which is just here. I'll go for that in a second, into this container, and then when DAQ runs this, when DAQ fires up the Docker container, we're going to simply run that bash script. That's what it is. So the bash script is this, and I'll go over each kind of part of this in shortly, but that is what test discover is. That is all it is. So this test is written in bash script language, bash scripty stuff. There are other tests in the subset folder, or other modules. So if we just have a look at the switches one, which probably did that run? Let's have a look. The switch test did run. Yeah. We have a look at the report for this. Then we can see the switch test just skipped everything because there is no physical switch connected. The switch test is written in Java, which is obviously not a bash script. But because, so the Docker file for the switch test looks like this. So again, from the DAQ base image, aardvark, just as an aside, the only reason that the base image is called aardvark is so because the code's lazy and it evaluates alphabetically. So don't call your test. I don't know, I suppose you need a special character and then aardvark, or aardvark with 3 A's, because that'll mess everything up. Yes. So back to the point in hand. So test switch is written in Java. And here's the code for the allied telesis bit here, and here's the code for Cisco switch. Here is all of the code for the switch interrogator. It's quite big. Anyway, the point is that it's written in Java. There is another test, which is, I believe in pen tests. Yeah, test brute. So the Docker file test brute is this. Again, we're using the DAQ base image, aardvark. We're installing Python, installing netcat once again, and we're copying a JSON configuration file. And we are copying subset pentest test underscore brute, which is here. This has a, just go into these things and close these down. Just want to get test brute and test discover side by side so we can compare these. So it's kind of all the same really. Both are shell scripts, but they both accomplish different things. So this test discover thing on the right here is a shell script, and it uses the nmap command to run a test. And then we parse the output of that nmap command and we do some reporting. Test brute kind of does a similar thing, but instead of using nmap, which is a kind of Unix utility, included in most distributions, well, it works on most distributions rather than being included, or is included within the repository lists. I'm getting ahead of myself. Test brute runs a Python script, and then within, I'm not fully sure how this Python script works, but the only real difference between test brute and test discover is that test discover uses nmap, which is a thing, and test brute uses a Python script. And test, and if we have a look at that again, if we have a look at test discover compared to the test switch here, then again, it's kind of the same thing. Test switch is a bash script, and we are doing some things, but instead of running nmap, like in the test discover, or running a Python script in test brute, we are running a Java file. Well, we're running a Java application here to do our test. So what that means is that DAQ is a generic test runner. So the test can be written in any language that you like and in any way that you like at all. So you can make the code as obfuscated as possible. You can make it as long as possible. You can make it as confusing as possible. Ideally, it should be easy to read. It's being an open source project. It'd be nice if other people could understand your code and extend it and dig in and find out why things have gone wrong if they go wrong. But that's the point. So if you have previously written some sort of penetration test for a device and it's a Python script or something and you just got it stored in your local machine, then you can convert that into a test that will run in DAQ fairly easily. If you have some crazy bit of software that only runs on Windows 98 or only runs on a really old version of Ubuntu or something, then if you can containerize your software, then you can containerize your software within the DAQ framework, then DAQ can run it. So DAQ as a framework. So I've kind of skimmed across this up until now, but what we're going to have a look now is how the framework side of DAQ works, and this is mainly focused around how DAQ runs tests rather than what the framework is doing. But just as a little primer, if we just have a look at the code, the directory structure of the code here, all of this is explained in the README. So if we go down to the bottom here, we've got a folder structure. The top level DAQ folders correspond to the following structure: bin, system setup, and things like that. There's also now a bin hack, so it's slightly out of date. But there we go. But all of these things, that is what DAQ is. On the forums, you might hear the words. Well, you might see DAQ. You might see two references to two things. So there's DAQ proper, which is the framework, which is essentially all of these Python files here. So these are this is the software that orchestrates. There's also a orchestrator and I believe an orchestrator as well. No, there isn't. These collection of Python scripts orchestrate DAQ. So they start faucet, they set up networking things, and then they run the tests. They read all the configuration files that you've written, and they produce reports. And when DAQ is done, it's these Python scripts that shut DAQ down, etc., etc., etc. There are a few tests that are included within DAQ proper, in inverted commas, and those are the ones that are in this Docker folder here. So if in your local configuration here, you took out BACnet like that, and we took out brute, and we took out MacOUI and Mudgee and password and switch and TLS. If you just had that, what I believe would happen is that the only thing that DAQ would run would be the test that are in here. So you've got test BACnet, which is a very simple BACnet test, which is not a patch on the BAC ext test, well, module. We've got a test fail, which always fails, as you can see there, command, false. We've got a hold test, which stays held. It's a test that doesn't end. It requires manual. It's just a test that acts as a kind of chock behind the wheels of DAQ. Mudgee, which is Mudgee stuff. Test pass, which always passes, and test ping, which simply pings a device or a switch. So that's DAQ proper. And then we move down to sort of tests that have been added by other developers. So each of these folders kind of comprises loosely a module. And then in some of these folders, there is a module manifest down here. So if you wanted to know what tests were part of the switch module, you would have a look in here. And if you wanted to know which tests were part of the security section of DAQ, then you'd have a look in here. Because basically what that implies is, if we go back to here, is if we configure DAQ to include the switch module here, so that's configuration modules, switch module here, it's going to look in basic terms, it's going to look in this switch area here. It's going to build test switch, and test switching comprises of these 6 tests. So that's just a very small overview. So when a test is run, very, very simply, one of these Python scripts here, I believe it's in here somewhere, but it doesn't really matter too much now because I'll go into that a bit later. One of these Python scripts will, based on your configuration, so again, let's talk about the switch test for a bit. If the switch test has been built and you've got a container called DAQ_switch, then a Docker container will be made, as we saw before, called DAQ_switch, and then all the tests within, well, whatever binary file that's defined within test_switch in this example, that'll run, and then hopefully produce some results. And then the kind of wrapper bash script, which wraps around the module binary, kind of parses all the results from a kind of like a report text file right here. So in this case, there's a monologue and some result lines, but the result lines for this particular bash script are here. The log is there, and then there are some kind of bash functions which write the result out to the report. So if we have a look in the inst folder from that last run that we've already completed, we can see in the reports, the PDF one, slightly nicer to look at. In the switch test, which is there, scroll past it, module switch does that. So the switch tests, DAQ runs this essentially. It runs this bash script, but this binary is run. That creates some reports in the local report file, temp report DXT. And from that, we produce some result lines in a temporary text file called results.switch.txt, and a monologue in monologue.switch.txt. And then we write out the monologue here. And in terms of, God, I've lost it. In terms of the log, a monologue is, in this case, there isn't a monologue because we've skipped all the tests. But in the case of is there one here? I wonder. There must be. Potentially there isn't a monologue here. Let's have a look. Anyway, what happens in this run of the switch test anyway is we go down here. So we write our result in our report file, which is this report right here. And we print the name of the test, which is connection.portlink, so that's there. We add instant dividers because that's what the reporting functionality does. We add in the description for the test, which is from the manifest here. And then we print out the result, which is from our result lines over here. And DAQ does that for every module that's configured to run in that particular run of DAQ. Oh God, that's not what I want at all. Okay, yeah. So how rates report, we've kind of done that. So the reports in Inst. So every device you've got plugged in that has a working MAC address will get a report. So kind of easy to hear that the report file name, the structure is report underscore, and then the MAC address of your device underscore, and then the timestamp of when that report was written to disk. So there will always be a markdown report and a PDF report. So that's what's happened from this run. So as I said earlier, and kind of realised it over my ways and made a little bit of a video to explain my mistake to do with the ephemeral inst folder. And the inst folder is from the last run. So if I were to do another run right now, which I will do in a second, not going to do it, then that inst folder would be deleted, and then a new one would be created kind of instantly with some defaults. There are also reports in the local folder. So if we just have a look at the report for 35, this guy here, yeah, let's do that one. So report underscore 3C5 and then ending OA. If we have a look in the local folder, and we have a look for 336508, there is another file which is called device reports, and these are the same. So in the local folder is where the last report for that device is. So how can I explain this? So that in the local folder, oh God, I'm muddling over my words. But what happens is you run DAQ, and a report from that run is copied to the reports folder. This file here, report underscore 3C5OA, is then copied to local site MAC addresses 3C5OA device underscore report. That's it. So if I rerun DAQ like this, and then close it down again, and then kill all my Docker containers, which have already died, then you can see here that my IDE is very thankfully, very helpfully telling me that this report in the inst folder, so we've got projects, inst reports has been deleted from disk, and it's gone. And if we look in the inst folder and then we refresh this again, it has indeed. No, I didn't quite finish deleting it, but the reports folder has gone, and yet within the local folder, and then go back to it, then that device report remains. So, yeah, and that's exactly how it was. So inst is ephemeral, but local site MAC addresses device report MD is kind of the saved report from the last run, from the last DAQ run that you've done. There we go, so that's reports. How it appears on the Firebase dashboard. So what I wanted to kind of go over very briefly now is, once again, if we run a test, doesn't really matter. So if we do and port equals port 1 here. Ooh, hello. Yeah. Are you going to be happy? So, by the way, my test for seeing if Google works is to type LOL into the search bar, generally because it's L and O very close to each other on the keyboard, and I can do L with an index, O with the second, and then I can press Enter key with my little finger on my right hand. Fortunately, whenever I type that, League of Legends comes up. So if you ever see that on my tabs, I'm not a League of Legends fan. It's just my test. What's happening? go back to the dashboard. I want to show you some different colours on the dashboard. There we go. So we have a look at port 1. Then some tests pass, some tests are a nope, and some finishes are fine, some finishes never get there, and some tests are red. The point of this is that the dashboard should be an at-a-glance tool to give you an idea of how a test run is going or how it has gone. So green means it's done, and usually it means that the test has passed. Nope, which is kind of like a grayed out box right here. Nope means that you have disabled the test. So that there could be a built Docker container for your test, but it won't have been activated in this run. Mir, or generally red, just means that the test has failed. And I believe mir is a contraction of module error. There is also SIR, which I believe means system error, which means something's gone very wrong indeed. Yeah, so that's the dashboard. And so every DAQ test, as I mentioned before, has a bash script wrapper. So if you want to go and look at the test switch, then maybe not test switch, if we have a look at test discover down here, each bash script has an exit code. If you're not familiar with bash, basically what this does is if the result is a pass, or if the result is an info, or the result is a skip, return 0. So that means if the result is a fail, then we return 1 from the script. And if DAQ realizes, well, if DAQ detects that a given test script has returned 0, then it'll be green on the dashboard. And if it's returned 1, then it'll be red on the dashboard. Kind of simple as that. So just have a look. Make sure that if you are writing a test or you're looking at a test and how it works, if you want it to do something else, then always say done on the dashboard, then just return a different code. And there will be some docs somewhere in there, again in the docs folder. That's our scope for this video. So the Docker build flow. So I kind of touched on this before. Whenever, let's just kind of do a quick recap. Got a module config, and I've defined that I would like to enable the, let's go to a different one, enable the nmap module down here. So we have a look for test nmap, and we have a look at the doc file for that. So DAQ aardvark, once again, is the base image for DAQ. And if you are looking for certain things, if you're trying to parse the DAQ source code yourself, then this might be a little bit of help, hopefully. So test nmap, for example, source is reporting.sh. Where is reporting.sh? Let's have a look. So reporting.sh is in the utils folder. So we've got all of our folder structure here. Scrolling down. Got utils, got reporting.sh. So if you're looking at the test nmap, and in Bash, if you're sourcing another script, then normally it's in the same directory. But how is it in the same directory? Because I haven't defined anything called reporting.sh in my Docker file here. Well, it's in aardvark, of course. So if you look in aardvark, then that is has another command. Let's go, some syntax highlighting. On line 20, we can see that we're copying utils /reporting.sh into there. We're also copying the retry command into there. So DAQ does a few clever things to do with retrying. And those should be available to all tests. Also, we are installing within the base image nettools, bash, iproot, ip=ping, tcpdump, trace, vim, DAQ, and nano. All those things are needed. So if you're looking for dependencies, or if you're writing a new test, for example, don't re-add vim and don't re-add DAQ, don't re-add nano. Just make sure you respect the build cache of Docker. Otherwise, builds will take longer than you expect. Okay, And the last thing is to kind of discuss briefly what logs that gives us in return from our test runs. So let's go back to that again, because hopefully our test run should have finished by now. A bit of spaghetti words there. So if we go back to here, just have a check. Yep, we're all done. Ooh, TLS term. So this could be quite a good example. Yeah, right. So I have literally just started a DAQ run, and something has gone horribly wrong. I'm pretty sure I didn't Control C it. Or did I? No, I didn't. Unless the dashboard just becomes slightly out of sync. Well, let's have a look anyway. So, logs that gives you in return. Let's use another example. Once again, use the example of the TLS test, because that's the one that drew my eye before. So, where do you find that? Test TLS. There it is. So what TLS does is, where are we? The DAQ subset security. Subset security TLS test. There we go. So this is another test that's written in Java. And if we have a look at the source code for this, somewhere there will probably be some logging. There we go. So your system error print line get certificate exception, and system error print line disable certification. So there is some logging to the standard error, presumably, if this is the Java that I know and appreciate at least. So there's some logging to the terminal. So if you were to build this Java file, I just need to like a JavaC, or you to do a Maven build something. I'm not a Java guy, and you were to run that Java file with Java run dot, I don't know what you do, or it dot Java, I don't know. Then you would see some output in your terminal. Because all of these tests run within Docker containers, all of that output is hidden because it's happening within loosely a virtual machine down there. It's happening with a container, not a virtual machine per se. Thankfully, DAQ gives us all those logs, and they live in the inst folder. So for the test TLS, we can see that. Got any fails? No fails. So there were 3 devices plugged into the virtual switch in this faux run. And if we have a look in inst, run port, and then the number of the port, and then TLS01, then, right. So there seems that there has been some sort of issue with the TLS test. Different example. Let's have a look at log for the nmap test. So let's have a look at tests. Nmap. Go down here. We've got a redacted log. We're echoing something here, echoing test target. We're echoing failing in a redacted log. We're echoing open ports. We're echoing all sorts of stuff which would normally come out in the standard out of our terminal if we were running this test outside of Docker. So if we have a look at nmap, we have a TMP directory which gives us an nmap log, which is what happened. We have an nmap report log, which is defined at the top here. nmap.report.log, redacted log. There you go. So the TMP directory that is defined within each of the running Docker containers is copied out here, as is the running config of this test. So I can see that for port 1, this is the running configuration, and we've got our configuration copied over from our local folder. We have a report.txt, so that is what is literally printed into the markdown report. We also have an activate.log, which is a full excuse me, frog in my throat. The activate.log is the full log from what happened in this Docker container. So if we just have a look at so if we just try and find something like testing target here. Oh, no, not that one. Testing target. Then we can see that's there. So everything that you echo out within your your test bash script that wraps whatever binary or whatever, or wraps whatever Unix utility that you want to use to execute your test. That will appear in activate.log. But interestingly, I'm going to try and figure out what happened to this TLS test. Because if something failed drastically, then as you can see here, so we have, so run port 1, we're looking now at the activate.log from test nmap, right there. And we have an activate log for discover, so that's another one. We will definitely have an activate.log for Mudgy. And we have an activate.log from maybe not switch, because probably nothing happened. An activate.log from nmap, I just looked at. We don't have an activate.log or a return code or anything else apart from a module config.json within the TLS test. So at this point, you can scroll up, but what if you've reset your terminal and you can't scroll up? Thankfully, DAQ also provides a full running log of what happened, which is useful. So if you ever have a problem with your DAQ run and you're asking a question on GitHub or on the message boards, then the most useful thing is literally just to copy your entire zip up your ints folder and give that to someone who can help. The idea is that the ints folder is, as I said before, a full structured snapshot, essentially, of what happened during your last run of DAQ. You can also see the last report HTML if that helps you at all. Probably doesn't. So let's just kind of go back and see. We'll just kind of go around. Let's have a look and we can see what's happened with this TLS test. There we go. So straight away, even though I've reset my terminal and lost my logs and my screen buffer forever, I can see here that if I just go to the command run.log and just search for, let's just test TLS a little bit. Mininet is saying, or rather DAQ is saying that DAQ TLS test is not available locally. Pulling it, it doesn't exist because I can't log in, and yeah, TLS isn't there, and we can see exactly that, which tells me that I need to rebuild DAQ because I've clearly no, I don't want to say that, because I have clearly forgotten to build DAQ after finding what modules I would like in my run, which is annoying, and I'm sorry, but there we go. But luckily, that was quite a good off-the-cuff exploration into why the ints folder is good and what logs can do if you look in the right place. Okay, so that's it for this one. And in the next one, we will dig a lot deeper into DAQ. It's going to be a simple thing of going through each of the folders and just explaining what they're for, and maybe digging a little bit deeper, or rather, definitely digging a bit deeper into the module test concept in DAQ. The long story short, for the next one, if you're not interested, because the next one may be quite long, is DAQ itself, the framework, is all this Python stuff within DAQ. If you're using DAQ as an operator and you're testing things, you don't need to touch the DAQ folder at all. The binary thing, some binaries, and if you're writing tests, you should have a very good appreciation of the subset folder, because that's where we'll be adding new tests in. The testing folder, because that's where integration tests happens. And that's kind of about it. The rest of how to make DAQ run is just a series of build, or potentially clean, build and run steps. That's about it. Okay, see you in the next one for some more video feedback.